Alright, ladies and gentlemen, this is going to be rearranging the formula and discussing how to algebraically solve for Pivner. Let's get started on this next video. Alright, so in this video what we're going to discuss is how we go through and rearrange this formula here. So, when I give you the problems, I'm always going to give you three variables. Our r is always going to be constant. So this is a variable that we're always going to assume is going to be present. If I don't give it to you in the problem, it's just going to be assumed that dependent upon the units, it's going to be 8.314, or it's going to be 0.0826, or it's going to be 0.08206. So this is a constant, and it's not a variable that we're going to have to go through and account for. Now, if I want you to solve for, let's say we're solving for pressure, okay? If we're solving for pressure, I have to give you V, N, and T. Otherwise, you're going to have to solve for two variables, and that's not going to allow you to go through and solve the problem. So in the problem, I have to give you at least three variables in order for you to solve for that last variable here. And based on our algebra skills, we can go through and rearrange this. So I can go through and rearrange this formula into a variety of different ways in order to solve for the problem. But remember, if I'm asking you to solve for pressure, I have to give you the volume, and everything in yellow is what I'm giving you. I have to give you the number of moles, and I have to give you the temperature. And it's assumed that when you go through and solve these problems here, that you know that the gas constant is either going to be this or this, depending upon what units we're solving for pressure, and units we have for volume and temperature. And I'm sorry, not necessarily for temperature, because temperature is always going to be in Kelvin. So it depends on our units for pressure and for our volume here in order to go through and solve this. So let's go through and rearrange the formula in a couple different ways, and then we'll go through and we will go and figure out how to solve for each of the different variables here. All right, so the first one is going to be what we just went through and talked about, and this is solving for pressure. So we are going through and we want to solve for pressure here. This is the first type of problem that you're going to go through and see. So if we are solving for pressure, all we have to do is get P by itself. The way that I'm going to go through and do that is I'm going to divide this side by V and divide this side by V. V divided by V, it's the same as going through and doing 2 divided by 2 or 1 divided by 1. If I do 2 divided by 2, it's equal to 1. So it's the same as if I was multiplying that P by that 1. But if I look at this, right, V divided by V, if I do V divided by V, it's also equal to 1. I have to make sure that I carry that to both sides. So when I'm solving for pressure, the new formula that I'm going to get is P is equal to nRT divided by V, where the number of moles multiplied by the gas constant multiplied by the temperature in Kelvin divided by our volume here. And remember, when you go through and multiply this across, these have to be in parentheses. Otherwise, if you don't put these in parentheses, you're going to do n divided by v multiplied by RT. And we want this entire thing here to be divided by our volume. So in order to solve for pressure, this is how we're going to go through and solve for it. Now, in a similar fashion, if we are going through and solving for volume here, well, it's going to be just the same as if we were solving for pressure, right? We're going to divide P by both sides. By doing this, right, this is equal to 1. So our volume then, if we're going through and solving for it, is going to be nRT divided by P. Remember, when we put this in our calculator and punch all this in, this has to be in parentheses. If this is not in parentheses, this will not go through and compute correctly. So I have to make sure that when I go through and complete this, I am accounting for this in a way that goes through and allows me to get the correct problem. But again, if we're solving for our volume here, this is how we're going to go through and do it. So if we are solving for the moles, we have to get moles by itself on this side. So how am I going to go through and do that? Well, I can divide this side by r, right? And then divide this side by r. This will cancel, and I'll get, if I go through and do this, nt equals pv divided by r. But I can divide this side by t as well, so this cancels. So all I'm left with here is n is going to be equal to p divided by rt. And remember, we are going through and accounting for both of these in parentheses, because if we do not, we will not get the correct number of moles. So the formula, if we're solving for moles, is going to be n equals pv over rt here. Now, lastly, we're going to solve for temperature. So we want to solve for temperature here. We're going to do it the same way that we went through and solved for moles. Divide this side by nr, divide this side by nr, cancel, 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 cancel. So in this case, T is going to be equal to PV divided by nr. So I need to make sure I put these in parentheses, especially when I'm going through and accounting for it in my calculator, or I will not get the correct temperature. Now, the only one I haven't asked you to solve for is R. And in most problems, you're not going to be asked to solve for R because this is a constant. Now, could you solve for R if I gave you P, V, N, and T? Absolutely. We could go through and solve for it algebraically. However, we're always going to assume that R is going to be, in most cases, 8.314 or 0.08206. So this is what we call a constant, and it's just kind of something that you have to go through and remember. It's not always going to be given to you in the problem that you're going to go through and solve for here. But again, we're going through and accounting for it as if it's a constant, and we're going to assume that that's what it is, depending upon our units for pressure and volume. And this will go through and make sense when we go through and discuss that. The only unit that we do not change is temperature. It's always in Kelvin. It's always going to be in Kelvin when we go through and factor this in. So if we're thinking about all of our formulas here that we would have to go through and solve for, we have pressure, we have volume. You can be asked to solve for the number of moles, or you could be asked to solve for the temperature. Pressure is P is equal to nRT. We're going to put that in parentheses, divided by V. Volume is going to be equal to nRT divided by P. Moles is going to be equal to N is equal to PV over RT. Both of these need to be in parentheses when you put them on the calculator. And then T is going to be equal to PV over NR. Both of these are in parentheses here. Now you can go through and memorize each one of these formulas, or you can go through and solve for them algebraically when you go through and approach these problems. My thing is I always go through and solve for it algebraically. It's easier for me to go through instead of memorizing them, but you guys are welcome to go through and memorize them if that's something that you're interested in doing. They're all here, and this is what you're going to be asked to do. But remember, in all of the problems, I have to give you 3 variables in order to go through and solve, and we're assuming R is a constant, so really you have 4 variables, and you're solving for that 5th one. So you need the 3 variables in order to go through and solve for this problem here. Otherwise, you physically cannot go through and complete it.